Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Expansion by Proxy 14. And here are the rules. We need to divide the grid into 9 regions that all consist of 9 orthogonally connected cells each, and we need to place the digits 1 through 9 in every row, column, and region once each. So this is typical chaos construction rule set. What is an orthogonally connected region? It means it's a region where you can go from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because to get from any cell in that region to any other cell in that region, you can just go through edges while staying within the region. Here's an example of an invalid orthogonally connected region, because these two cells, while they can go to each other by going through edges while staying within the region, they cannot go to any other cell in the region just by going through edges while staying within the region. They either have to go through a corner or they have to go through an edge but exit the region, neither of which makes it a valid orthogonally connected region. So that's what orthogonally connected regions, that's an example of how they work. So that's 1, which is chaos construction rule set. 2, we have clues on the grid show the sum of the first x digits along a given direction, including themselves, where x is the digit in the clued cell. Furthermore, the first x cells all belong to the same region, and there are no other cells that belong to their region in the direction of the arrow. Okay. So say for, well, this is obviously not going to work. I guess let's do something like... Let's do something like this. So for here, we have a digit x, which is the digit in the cell. So in this case, we'll make the x 3. Then we could have 4 and 5 here. And the first x cells all belong to the same region, so that's valid there. And there are no other cells that belong to their region in the direction of the arrow, which is true. These 3 cells belong to the region. This does not, because the first 3 cells belong to the same region, but no other cells in that direction can be. And finally, a question mark can be any number from 1 to 45. So this, if this were the sum, this would have to be 2, because the first 2 cells all belong to the region, and there are no other digits. It could not be 1 here, because if that were 1, that would say that this cell by itself belongs to the region, but no other cells in this direction also belongs to that region, when we do have one that does. So that's why this would have to be 2 in that case. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's put a border around the entire grid to start. And the one that I spot is that these cells must add up to 810. And it has to be just these 2. Because if it were any further, these would all be in the same region. But then the problem is these must add up to 13, and that's already greater than the 10 that these can add up to. So therefore these 2, and obviously this has to be 2 digits because this has to be a different region. And these 2 must be in the same region. So this is 2 and 8 to add up to 10. And this is a different region here, and we have, it cannot be 2. It must be at least 3. It can't be 4. 4 digits adding up to 13 could only... Actually, it could be 4. Okay, so this is 3 or 4 here. So these are 3, at least must be in the same region. I don't know if there's more. This is 21. You can have, it has to be more than 3, so it's at least 4. Be 4, 5, or 6 here to add up to 21. So 4 of these are in the same region. This could be, well, it can't be just a singleton 1. So this is 2 or 3 here. We're not sure which. So both of these are in the same region. This is a question mark. This is 14. It has to be at least 3 digits here. This adds up to 14 also, so that's at least 3 digits. It can't be 2 digits because they would have to have 2 as the x, and 2 plus 12 would have to add up to 14, which is obviously not going to work. So this is at least 3. It could be up to 4. Can't be 5 because 5 unique digits must add up to at least 15. 1, 2, 3, 4, 5. So this cannot be blue here. Because again, you only have 3 digits in or 4 digits here, and there are no other digits that are part of the same region in that direction then. This has to, again, it cannot be 2, it could be 3 or 4 here. So these are part of the same region. Could be all 6 here. 7, 8, and 9, right? That is possible still. No, it's not. So if we tried to have all 6 of these be part of the same region, these 3 have to at least be part of the same region to add up to 14. Therefore, we have to connect them, and therefore these would all be blue. But the problem with that is this only sees 1 cell in the same region. And this cell sees only 1 cell in the same region, and we'd have a duplicate in that region. So this cannot be blue. We're going to make that orange. It has to be orange going down at least there. So this cannot be 6. It's 4, 5. Um, um, This is at least 3 or 4 also. They're part of the same region. We don't know which one, though. 12 cannot be. It's 3 or 4 also. 25. That must be guaranteed 4 cells. Because you can't have 3 digits adding up to 25, including the 3. So this is guaranteed to be 4. It must be all 4. So that's green. That means this in this green region, we can't have 4, so it must be 3. So that's 3 there. This is boundary there. And these 2 must add up to 10 without a 3, and without 2, 8, and without 4. So it must be 1, 9 as a pair. Well, if this were 1, 1 and 4 only add up to 5, and then we'd have to have 2 digits trying to add up to 25 minus 5, which is 20, which is not possible. So this must be 9 here. We have to have 9 there, 1 there. This cannot be part of green because we have 3 and 4 already accounted for in that region. So this is boundary. 4 and 9 add up to 13. 25 minus 13 is 12. So the remaining 2 digits here must add up to 12. We don't have 3, 9 available, no 4, 8 available, it's 5, 7. So this becomes 5, 7 as a pair. That means the remaining digits in row 6 are 1, 2, 3, 6, and 8. Okay. Um, what else do we have? Obviously, this could be part of that section there. We don't have very many restrictions there. 3 eliminates 3 here, so this is a 4. So all 4 of these are the same region, and then we have a boundary. It could be same as orange. No, it cannot be the same as orange. If it's the same as orange, this would have to be 4, because these would all be part of the same boundary. So this must be 3 here. That means this cannot be 3 there. We have boundary there. Boundary here. No more 3 here because of 3 in the column. Remaining digits add up to 10 without 3 and 4 available in the yellow region. So I think it has to be 127. 14 minus 4 is 10, right? You would have normally 127, 136, 145, or 235, but 3 and 4 eliminate everything but 127. Okay, so that's 127, which eliminates 127 in the rest of the row. So we have 5, 6, 8, and 9 left. Remaining digits in row 7. Okay. Of these digits, the only digits that can be green are 6 and 8. But that's still a wide variety. This can't obviously see 8 cells this way. This can't be 3, cannot be 4. It can... Okay, so each of these digits can go a certain amount. So this can't go 3 digits. So this is... It can't be greater than 3 because we only have 3 cells in that direction. So this is 1 or 2. Same with this. This can be up to 4. 1 through 4 there. This could be a... It has to stop at the yellow. Because if it's part of this, if it goes all the way down to orange, it cannot be part of yellow. So this is 1 through 5. This cannot be 3. It could be 1 through... It can't... It could be part of the orange, though, technically. So it's 1, 2, 4, 5. No 4 here because of 4 in the column. This is 1 or 2. Going that way. 2, 3 there. 3, 4 there. It's going to be 5 also. It's 18, right? Yeah, that could be 5. It's very unlikely to be 5, but it could be. Yeah, it could be that. This can go include green, so this could be 1 or it could be 2. It could include green. If it includes green, does that even work? 1, 2, 3, 4, 5, 6. It would be 7, 8, 9 at most, but then that would be 3 or 4. So this cannot include green. It has to be 1 or 2. Okay. This we're not sure of. This is 5 at most. So it's 1 through 5. This could be all the way up to 9. Actually, remaining digits in column 1. We have 4, 5, 6, and 7. Okay. So those are the possibilities there. Hmm. Also, because this is only 1 or 2. It could have been 1, 2, or 3. Then this could never have been 6, because it would require all the digits 1 through 6 to add up to 21 if they were all 6 digits. Okay. This can't be 8 cells that way. It could be 1, 2, 6 is not possible either for an orange, right? These two must add up to 11. So you can't have 6 here. 1, 2, 3, 4, 5, 6. You have to orthogonally connect the orange region, and there's too many cells required to do that. So this can't be 6, it can't be 8. We must add up to 14 here. That means this has to be 2 and 9. That eliminates 2 in the rest of the row. That means we have to go 2 that way. Okay, so these are all part of the same region. Interesting. This is definitely a different region. This is definitely a different region. And the rule set saying that you can't have, these are all part of the same region, but then there cannot be any more part of that region be part of that region. Means that blue is different from yellow. So we're kind of enclosed here. Yellow can go here, though. Yellow could extend. We own... How many cells do we have here? This is 14. Plus 3 is 17. Now, blue obviously has to go some portion this way. It cannot be 2 digits this way. If it's 2 digits, the problem is that 2 plus this digit is never going to add up to 9. So this has to be 3 here. So we have to have 3, and these 2 digits must add up to 9. So this is 4 or 5 here, and this must be 1 or 2. So these are all part of the same region. This must extend to there. We have a 1-2 pair now in column 2. Okay, that means the remaining digits in column 2 are 3 through 9. No 3 here. No 8 here. These have to be different regions. 3 eliminates 3 here. Not sure about the rest. Oh, because this could be 5. Right. Well, still, you still had to be 5 and 7 here anyway, so this couldn't be 3, 4, or 5. Let's see. This digit cannot be 1, 2, 3, or 9 because it's in the orange region, so it's 4, 5, 6, 7, 8. Hmm. 1, 2, 3, 4. 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is possible. Again, we have 17 digits here. 7 of them are taken up by red. 3 of them are taken up by at least blue, right? Because blue is stuck here and then can only have to have 3 there. So that's 10 accounted for, which means we cannot form a full region here. Which means green can only go 2 more, or 3 here, but it can't block red off. So green could get to here. It cannot go here because that would be 3 then in the region, or 4, but the problem is we already have 3 or 4 in the green region. So green cannot extend to here. So green could go all the way to here, possibly. Red could be all of these up to here and here. Yellow can be everything up to here and maybe here and maybe here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we could. So yellow, heck, yellow could even go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The problem is yellow cannot get to here. So blue can get 5 more. So these could all be blue. Okay. This can't be green. If we try to have green, 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 this is only 3 going that way, so this can't be green. Could have 2 there. So green has to have 2, 6, and 8 adding up. The most that are accounted for in this set. Yellow could do something like this. That is possible. Can this be blue going here? I guess red could, right? Yeah. I mean, this could be part of yeah, this could be part of yellow also. This has to be blue, orange, or yellow, and this is blue or orange. Don't know which. This could be something coming in. So guaranteed, or what's the max for these digits adding, being blue and red? We have 7 reds left and 5 blues at least, at most. So that's 12. So 5 of these at least have to be yellow or green. Okay. Does that tell us anything? I'm not really sure. Can this actually be 5? 1, 2, 3, 4, 5, 6, 7, 8, 9. Possibly, yeah. Still could be 5. This can't be red. If this were red, the problem is you would see 3 or 4 going this way, but then we would have another red going in that direction. So this cannot be red, which means none of these can be red, which means this is either blue or yellow this way. If it were 4, it would have to be blue then. That is interesting. Okay, so this can't be blue. So if we try to make this 4, it can't be part of yellow because yellow already has a 4. It would have to see 4 blues this way, which means blues would have to go all the way over here. And then this would not be 4, it would be 5 because we already have a 4 in the blue region. But that's too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, this cannot be blue. It has to be yellow, and it must be 3. So that's 3. Blue, then, has to definitely contains these 3, because there's no other place for it for this region. So these are all blue. This doesn't have to be. This is definitely all blue. So we see 3 yellows. These cannot be yellow. Therefore, that makes that red. This cannot be 2 because of the 2 reds. So this can't be red here. This is 1. Because we already have red in the region. 3 eliminates 3 here. We only have 2 more yellows left. So this can't be yellow here. We cannot get to yellow here. So it could be 1, 2. It could be 1, 2, 1, 2. These add up to 14. 14 minus 3 is 11. No 3, no 2, no 4 available, so this must be 5, 6 as a pair. That eliminates 5, 6 in the rest of the row. So remaining digits in blue cannot be 1 going this way. It has to be 2. So then this is blue there. This is 2. No more blue there, obviously. So we have boundary here. Boundary here. We have 1, 2, 3, 4, 5, 7. We have 2 more. So this can't be blue here. This is red or green. We have just 8 and 9 remaining for yellow. Remaining digits in row 8 are 4, 7, 9. No 9 here because of 9 in the column. Can it be 4 digits adding up to 21 here? Yes. Still could. We have 1, 2, 3. Okay, so this is boundary here. If we tried to have yellow, yellow here, that would mean 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that could work for red. Oh, this is 2 this way, so this cannot be orange. So therefore, this can't be 5. Because there's no more digits in that direction, which are orange. Okay. This cannot be 8. So we have an 8 already in the red region. So this is 3, 4, 5, 6, 7, 9. We have 1, 4, 3, 1, 2, 1, 2. Uh. Hmm. Oh. Red needs a 3. So does blue. Where is red's 3 going to be? It's going to be in row 9. That means blue cannot have a 3 anywhere in row 9, can't be in row 8, can't be in row 7. Where's the 3 that's going to access? It can only access 3 here. So this can't be yellow, or this is guaranteed to be blue. So we know that's blue. This then has to be orange, because there's no other way to orthogonally connect this. And have this be part of another orthogonally connected region. If we try to basically make this part of another orthogonally connected region, that would block these from connecting. So this has to be orange there. And this must be the 3 for the blue, because there's no other place for 3 for the blue. 2 eliminates 2 there, so that's 1. This could be part of orange, we don't know. That eliminates 1 in the rest of the column. Okay. Can it be 5 anymore, adding up to 21, without 1 and 3 and including a 2? So the minimum for 5 digits would be 2, 4, 5, 6, 7. 5, 6, 7 is already 18 plus 2 and 4 is 23, so this cannot be 5. Therefore, this must be 4. So then we have a boundary here. Oops. We have a boundary here, and this is not blue. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. This can't be red or yellow. This is blue. This can't be blue anymore, so this is boundary there. 4 eliminates 4 there, so it's 7. No more 7 in the row, so it's a 4-9 pair. To add up to 21, we have 21 minus 2 and 4 is 6. That's 15 left. So this is either 6, 9, or 7. 8 cannot be 7 because of 7 already in the box. No 7 there. So this must be 6 and 9. That means the remaining digits in the blue region are 1, 5, and 8. That eliminates 1, 5, and 8 in the rest of row 9. So that leaves... this can't be 4 anymore. This is 3, 6, 7, 9. Therefore, this cannot be yellow, yellow, because the yellows require... We need 2 eliminates 2 here. We need another 8 and 9 for yellow. And if this was yellow, yellow, none of this would be 8. So this can't be yellow, it's red. We cannot cut off the green. 4 eliminates 4 there, so that's 9, which makes that 4. No more 9 here. It's a 9 in the column. This cannot be green, because green already has a 9, so this is part of red. Which means in red we cannot have another 9, so this becomes a 3, 6, 7 triplet. That eliminates 3, 6, 7 in the rest of the row, so this can't be 3, 6, or 7. It's 9, and again, red cannot contain a 9 because we already have a 9 for red. So that's done. We have 1, 2, 3, 4, 5, 6, 7. This can only go 8 there, so this is guaranteed to be... Well, can't be green because green already has a 4. So 1 out of these 2 is a red. We don't know which. Yellow cannot... We already have 8 yellows now, so this can't be yellow, which means this must be green. So we have 6 or 8 there. 9 eliminates 9 in the rest of the row. So one of these is 5 and is red. You still could have yellow there. 4 eliminates 4 in the rest of the column. 3 eliminates 3 in this column. 6 eliminates 6 here, so it's 1, 8 as a pair. Remaining digits of orange. So remaining digits of column 9. We have 5, 7, and 8. This is a boundary here because it's only one cell. It's probably part of orange. One eliminates one here, so that's 2, which makes that 1. So that's done as a boundary. This must be 3, 1, and 5 to add up to 9. So no 1 here, no 5 there. So this is light, and then this is boundary. This is 2. It's not going to be light because this is no longer part of light. It still could be 5. Can it be 5? I don't know if it can. Because if it's 5, that's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then this is not going to be able to form 2 full regions that way. And even if we go 1, 2, 3, 4, 5, 6, 7, 8, and 9, that's still not enough to form 2 valid regions, and these have to be 2 valid regions here. Because this is not going to be the same region as this, because we already have, by this going 5, it's too big. So this has to be 3 then. It could be still part of pink now, but if it were 5, it would not be able to be. Oh, even if it's 5, it goes too far that way. Right? 5, it has to go 2 at least that way, so that's not possible. This can't go 5 anymore. It can go 4 at most, can't go 3 because of 3 in the column. This could be part of pink. In fact, it's very likely to be part of pink. But 3 eliminates 3 in the rest of the column. 5 eliminates 5 in the rest of the column. This is 4, 5, 6, 7, 8. Remaining digits of row 5 are 2, 4, 5, 6, 7, 8. No 4s here because the 4 is in the column. 5 are part of the region. 2. So if this is 4, these are all part of the same region. If this is 2, this has to get out somewhere, and it's not part of that region, so it has to be part of here. So no matter what, these are part of the same region. Okay. These add up to 18, so it's either 6, 9, or 7, 8 here. This can't be 9, so this can't be 6. Because these 3 must add up to 18, because 18 minus 3 is 15. What else do we have? Green needs access to a 2. Well, we could do green, green. We could go green, we could go green. That's fine. This cannot be 4 anymore, adding up to 12, because we don't have a 2 available. So if we try to add up to 12 with 4 digits, it has to be 4 with 1, 2, and 5. But we don't have 2 available. So this must be 3, and it has to be 4, 5 as a pair. And then there's a boundary. So this is definitely part of orange. So this is 3, 4, and 5 here to add up to 12 because we don't have 1 or 2 available. And that means the remaining digits in this row are 6 through 9. No 9 here. There's 9 in the column. Where is the 9 in row 3 then? It has to be here. So this is 9. That eliminates 9 and 6 as a possibility there. So this is 7, 8 as a pair. These three are all the same region. This is definitely orange. So 1, 2, 3, 4, 5, 6, 7. We have 2 more for orange. 3, 7, 8. This cannot be part of orange anymore. So this is not 4. It's either 1 or 2. We have a 1, 2 pair in column 8. That eliminates 1 and 2 in the rest of the column, so no 1 there. Remaining digits in column 2, or so column 8 are 4, 5, 6, and 8. No 5 here because of 5 in the row. Remaining digits of row 1 are 2, 4, 5, 6, 7, 8, and 9. No 4 or 9 here because of 4 or 9 in the columns. No 2 here because of 2 in the column. Where is 9 in row 1? It has to be here. So that's 9. That gives us a lot of 9s. We know one of these two is a 9, and we know one of these two is a 9. It's not that helpful, though. This is not part of orange. What else do we have? We have a 1, 2. Yeah, 1, 2, 5, 6, 8. 1, 2, 5, 6, 7, 8 sextuplet in column 5, which eliminates 1, 2, 5, 6, 7, 8 in the rest of the column. So this is 3, which is not part of the light region, because we already have a 3 in the light region. Oh. This is very closed off then. Where can light go now? Light cannot be part of this because that's 3 cells that way. Can't be part of that 3. So light is guaranteed, can't be here because this sees only 1 cell as part of its region, which is itself. So light is guaranteed then to have to go this way. Those are the only places that it can reach to because it can't be part of this. Pink is a different region. This is a different region. 3 is a different region. So that's done as the light region. Which means pink is going to have to be the same as this region. So this is pink because there's no other place for it. Pink has to go there. That's 1, 2, 3, 4, 5, 6, 7, 8. That means it must connect orthogonally there. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's done as a region. No more. How did I have 5 there? No 5 there. 2, 6, 7, 2, 4, 6, 7, 8, 9. 7 and 8 eliminate 7 and 8 in the rest of the pink region, so no 7 there. It's 6, no 4, 6 or 7 there, it's 4. So no 6, 7, 8 here, it's 5, 9 as a pair. That leaves this as a 1, so this can't be 1 there, it's 2. 5, 9 is a pair, eliminates 5, 9 in the rest of the column. So no 5 there, it's 7. No 7 there, it's 6. No 5 or 6 there, it's 8, which makes that 6. 8 cannot be part of red, so this is green. That's done as a boundary there, so this has to be red there, and it has to be 5. No yellow or green. That 7 eliminates 7 there, so it's 5. No more 5 here. 6 eliminates 6 here, so it's 7, which makes this 3. No 6 here. 7 eliminates 7 here, so that's 8 and 7. No 7 or 8 here, it's 2 or 4. 2 eliminates 2 here. No more 5 there, no more 7 there, no 7 there. It's left 2, 6, and 8. We have 2 and 4 remaining in column 3. 4 and 6 eliminate 4 and 6 there, so it's 7. That eliminates 7 in the rest. Of the region. So we have a 2, 6, 8 triplet, which eliminates 2, 6, 8 in the rest of the light region. So this can't be 2. It's 4, which makes that 2. Green needs access to a 2, and if this were something, if we cannot access this 2 there, so that means this must be green. So that's done as a region. One of these is yellow. We don't know which. 2 is here. This cannot be orange, so this is a different region. We'll mark that as medium. You cannot orange cannot access a 1, neither can yellow. So the 1 that's here has to be accessed by the medium. So therefore this must be medium here. It must connect there. It must connect there. And this cannot be, that means yellow has to go this way to connect to an 8. So we have boundary here. This is boundary here. So this cannot be 8, it's 1. Or yellow has to have an 8, so that's 8, which makes that 1. We have to orthogonally connect. It could either go that way. This can't be 6 or 7, therefore this is 8. Or we could have 3, 4, 5 going that way. Either way, where's yellow? Orange. 1, 2, 3, 4, 5, 6, 7. It has to be 8 and 9 there. So that's orange, orange there. Interesting. Okay. No more 8. 8 eliminates 8 there, so that's 6, which eliminates 6 here. So that's a 2, 8 pair. That eliminates 2 and 8 in the rest of the column. So no 8 here, it's 6. No 6. 6 eliminates 6 here, so it's 5 and 6. This can't be 6, 5, 6, or 8. It's 7. That eliminates 7 in the rest of the row. 6 can't be here. This is a 4, 5, 8 triplet. That eliminates 4, 5, 8 in the rest of the orange region, so no 4, 5, or 8 there. It's 6, which makes that 7. 6 eliminates 6 here. This is 2, 4, 8 as a triplet in row 1, which eliminates 2, 4, 8 in the rest of the row. So no 8 here, it's 7. No 7 here. These are different regions. This has to be 5 or 9 remaining in row 4. Okay. If this were 4 connecting to this would have to be a different region because this has a 4. And so this 4 would have to go, I guess it could. Oh. These are part of the same region. How does that work? 7 eliminates 7 here, so that's 1, which makes this 2, which makes that 7. Okay, that's helpful. 2 eliminates 2 there, so that's 1. 1 eliminates 1 here. We have a 4, 5, 8 triplet in column 7. That eliminates 4, 5, 8 in the rest of the column. So that leaves this as a 6. 8 eliminates 8 here. Remaining digits here are 2, 5, 8, and 9. No 8 here because of 8 in the column. We have a 2, 4, 5, 9. This is a 5, 8 pair here in row 9, so this must be 1. This is a boundary here. So this is a different region than this. Medium needs access to a 4. Where is it going to get access to a 4? It cannot go this way, because then that would be too large, because that would force this to be 4 cells to be part of the region. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah. So it needs to access this. So then this is medium. We have 1, 2, 3, 4, 5, 6, 7, 8. We need access to an 8, and therefore that's the only one. So that's done. So then these are the regions. This 4, 5 pair eliminates 4, 5 in the rest of the region. No 5 there. It's 9, which makes this 5, which makes that 9. This must see 4 cells to be part of the region. So this is 4, which makes this 8, which makes that 2, which makes that 8. No 8 here, it's 5. No 5 or 9 there, it's 2. 4 eliminates 4 here, so it's 5, which makes that 8. No 5 or 8 there, it's 4, which makes this 5 and 4. 5 eliminates 5 here, so that's 8 and 5. And that's the solution. Fairly straightforward. Pretty cool, actually. I liked how these internal x sums interacted. And yeah, it was just nice. Never felt like I was stuck at all. It just kept flowing from one to the next. Yeah. Nice little puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.